Russ Jackson, welcome back to the show. Today we're diving into error handling in Rust, specifically the panic macro. So, tell us about this panic macro.
Hey Matthew, thanks for having me. Panic is like an emergency stop button in your Rust code. It's for situations where something truly awful has happened and there's no graceful recovery.
So, a crucial error condition.
Exactly. Think of it like a broken gear in a machine. You can't keep running, you have to stop.
How does it work, practically speaking?
When your code hits a panic, it prints an error message, unwinds the call stack, and then exits the program. It's basically a controlled crash.
So, like a try-catch block, but more dramatic.
Well, it's not exactly a try-catch in the sense that you don't have recovery, but you do get a detailed failure report.
Why would you use this?
Situations like accessing an array outside its bounds, dividing by zero, or encountering data corruption. In these cases, the program can't proceed safely.
What's the difference between unwinding and aborting in response to a panic?
Unwinding cleans up the data on the stack, a bit like carefully shutting down a computer, making sure all the files are saved. Aborting is a quicker way to quit, leaving things as they are, so the OS has to clean up afterward.
Sounds more like a graceful shutdown or forced shutdown in that respect.
Exactly. If you want to make your program smaller, aborting is better.
And how do you specify aborting instead of unwinding?
You add panic equals abort to the appropriate profile sections in your cargo.toml file. If you only want your program to abort in release mode, for example, you configure it that way.
You mean something like this, profile.release?
Exactly. It tells the compiler to use an abort instead of unwind in release builds. This reduces your executable size.
How can I figure out why the panic occurred?
The error message gives you a file name and line number. If the panic originates from a library, that file won't belong to your code, and you can trace back using the backtrace.
A backtrace?
Right. It's a list of functions that led to the panic call, allowing you to pinpoint the source of the issue.
Can you explain the rust_backtrace equals one environment variable?
That's how you request a more comprehensive backtrace in the error output.
So panic is for when things go wrong in ways that can't be easily fixed.
Precisely. It's a crucial mechanism for robust error handling in Rust. It prevents crashes in your code that might otherwise corrupt data.
Okay, Russ Jackson, that's a fantastic overview. Thanks for explaining this error handling in Rust. Russ Jackson, welcome back to the show. Today we're diving deep into error handling, specifically panics in Rust. Can you give us a high-level overview of what a panic is?
Sure, Matthew. A panic in Rust is basically a way for your program to abruptly stop. It's different from a regular error, which can often be handled. A panic signals that something truly catastrophic has occurred, like trying to access a non-existent element in a vector.
Okay, so it's kind of like a crash, but more structured?
Exactly. It's a controlled crash, hopefully with a clear explanation of why it happened.
And you mentioned vectors. Let's say I have a vector with 3 elements and I try to access the 10th.
You're hitting on a key concept, Matthew. Rust's type system, and the way it manages memory, prevents what's known as a buffer overread. If you try to access data outside the bounds of the vector, the Rust compiler knows it's a problem that needs immediate attention. It's a safety feature.
So, it's more than just a return or a throw in other languages?
Exactly. It's an interruption to program flow. When the vector's bounds are violated, Rust prevents the program from accessing invalid memory addresses, a critical aspect of memory safety in Rust.
And how does Rust signal this panic? Is it like a special function call?
It's handled by the panic macro. That macro is part of the standard library. In our example, if you attempt index access outside the vector's boundaries, the panic macro is invoked internally by the code that's running the index access.
So, what's a backtrace and why is it important in this context?
A backtrace is a record of every function call that led up to the panic. It shows you, in a stack trace format, where the program was, what code it was executing, and who called whom. This is extremely valuable for debugging, especially when the panic originates in a library function that you didn't write.
How does the rust_backtrace environment variable fit into this?
Setting rust_backtrace to a non-zero value tells the compiler to include a backtrace when a panic occurs. This shows you the sequence of function calls leading up to the problematic line in your code.
So, looking at an example from the text, you're telling me the problem is in my code, not the library's code?
The backtrace helps you pinpoint where your code went wrong. In a panic involving library code, like a vector index out of bounds error, the backtrace will show you the function calls leading to that failure point.
And how do you fix these out-of-bounds errors?
You need to validate your indices before attempting to access them. For example, you could use a loop or conditional statement to ensure your indices remain within the bounds of your vector. A common mistake is accessing the last element, not realizing it's at index n1 instead of n.
So, the fix involves checking the vector's size, right?
You need to be careful of potential integer overflows and ensure the index isn't out of bounds. Using a for loop to iterate through the elements, or using an iterator over the elements, are both safe approaches.
You've touched on debugging, but what are some common misconceptions about backtraces and panics?
One misconception is that backtraces are always easy to interpret. Sometimes, particularly in large programs or complex library code, they can be very dense and require careful study. Another common misconception is that panics are always detrimental. Sometimes, they are essential for preventing unexpected program behavior.
In your view, when should one use panic? And when should one use a more robust error handling mechanism like result?
Use panic for exceptional, unrecoverable situations that indicate a bug. Use result for errors that can be handled gracefully. A good rule of thumb is panic on bug, handle error.
Thanks for breaking this down. It's a huge leap forward in understanding how Rust handles these crucial aspects of programming.
My pleasure. Let's discuss result in more depth next time.
Russ Jackson, welcome back to the show. Today, we're diving deep into recoverable errors in Rust. Let's start with the basics. What exactly is a recoverable error?
Hey Matthew. A recoverable error in Rust isn't one that crashes the program. It's one where a function encounters a problem, but it can still give you some useful information to handle. Think of it like trying to open a file that doesn't exist. Instead of just halting, you can get details about why it failed.
So, it's like a graceful exit instead of a sudden crash?
Precisely. A graceful exit, letting your program keep going.
And how does Rust help us manage these recoverable errors?
Rust uses the result type. It's like a container that can hold either the successful value, the OK case, or an error description, the error case. It's very common in file handling, network requests, virtually any operation that might fail.
Can you give a real-world example in a financial context?
Sure. Imagine a function that fetches account balances from a database. If the database is down, you want to know about the problem, rather than just crashing the entire transaction system.
How does the result type facilitate error handling?
You use a match statement. You tell Rust what to do with the OK case, giving you the balance data, and what to do with the error case, handling the database error.
Walk me through a simplified example.
Let's say we attempt to open a file. If the file is there, it returns the file handle, the OK case. If it's not there, it returns error information, the error case. The match tells Rust how to respond to each situation.
So, match is our error handling control flow?
Correct. Match essentially checks if the operation succeeded, OK, or failed, error, and directs the program accordingly.
How do we avoid panic?
Instead of panicking, like our example did with panic, you can decide to log the error, retry the operation, or take other suitable action. In financial applications, logging the error to a database or an error queue and retrying the operation later is crucial.
That makes sense. What are some common mistakes with this approach?
One common error is forgetting to handle the error case. If you only handle the OK case, your program will crash on failure.
What are the different ways we can handle the errors effectively?
You can log errors, display messages to the user, retry the operation, or return a default value.
What if, during database retrieval, we need multiple things?
You can chain result S, combining data from multiple operations within a single match.
Excellent, that's very helpful.
The key is to handle these recoverable errors to avoid unexpected crashes. This also prevents cascading errors that can halt larger processes.
Thank you, Russ Jackson. This has been very insightful. Russ Jackson, welcome back to the show. Today, we're diving into error handling in Rust. You mentioned unwrap and expect. What's the deal?
Yeah, Matthew. These are super useful shortcuts for handling result types in Rust. Essentially, result encapsulates either success or an error.
So, it's like a container that holds either the result or some kind of problem, right?
Exactly. If you have a function that might fail, like trying to open a file, result lets you handle that. Unwrap is a simple way to get the value if the result is successful.
So, if the file opens, you get the file handle. But if it fails?
It panics. That's the crucial difference. Unwrap immediately stops the program and gives a somewhat generic error message.
Ouch! Sounds like a bad habit. What if we need more context?
That's where expect shines. It also panics if the result is an error, but allows you to customize the panic message.
So, you're saying it gives you a more informative error message?
Absolutely. You can say, failed to open file, hello.txt, instead of the generic panic message.
Why is this useful in the context of, say, a financial transaction?
Imagine you're validating user input for a transaction. Unwrap might panic without telling you the specific reason why it failed. Expect allows you to see, input validation failed, insufficient funds.
So, expect is like a more informative crash report?
Precisely. It helps pinpoint errors in complex code.
But what if I don't want to panic? What other ways are there to handle errors?
Good question. Match allows a more controlled approach. You examine the result, OK or error, and decide what to do in each case.
So, match lets you deal with errors gracefully instead of panicking?
Right. You could log the error, retry the operation, or even return a default value. Unwrap and expect are excellent for situations where you want to stop immediately on a failure, but you need a more robust way for more complex error handling.
Makes sense. Any potential downsides to unwrap or expect?
Yes, if you don't use expect properly, you could make a silent panic that can be challenging to find. Using expect makes you more aware of possible failure scenarios.
Thanks for clarifying that. Russ Jackson, this has been enlightening.
Thanks for having me.
We'll be back next week with more Rust exploration. Hey, Russ Jackson, welcome back to the show. Today we're diving deep into error handling in Rust. Can you break down this concept of propagating errors?
Sure, Matthew. Think of it like passing a baton in a race. Instead of a runner handling a problem themselves, they pass it on to the next runner who's better equipped to deal with it. That's error propagation.
So, a function doesn't try to fix everything?
Exactly. If something goes wrong inside a function, it doesn't try to handle it internally. It returns the error to the calling function, which then has more context to decide how to respond.
Why is this important? Like, what are the practical advantages?
Well, imagine you're reading user data from a file. One function might handle opening the file. Another function might read the data. If opening the file fails, it makes sense to pass that failure information back up to the higher level. You might have a default value if the file is missing, or you might even log the error appropriately.
So, how does this work with code? Let's look at an example.
This function tries to read a username from a file called hello.txt. If the file doesn't exist or if the read fails, the function doesn't try to handle it. It returns the error to the caller. The error type is result. This means success returns a string, the username, and failure returns an error.
Okay, I'm seeing it. Can you show me a match block example?
Sure. This function uses a match statement to check the result from file, open. If there's an error, it returns that error immediately to the caller. This is a basic way to propagate errors.
So, the match statement makes sure the errors are passed back correctly?
Correct. The match statement in this case ensures that if there's a problem, like the file not being found, that error gets passed back to the calling function to handle. This is a good method, but it can get repetitive with lots of nested matches for numerous checks.
This sounds like a crucial concept in financial systems, like when checking balances or verifying transactions. If one stage of the process fails due to invalid data, it has to pass that error up the chain, right?
Absolutely. The same principles apply. Errors in financial transactions need to be appropriately reported, which might involve logging, retrying, or even escalating the issue to a human.
There's a shortcut, right? The question mark operator.
Yes. The operator is a convenient way to do this same error propagation more concisely. It's equivalent to the match block and checks if it's an error. If so, it returns the error. If not, it returns the success value.
That's significantly cleaner. Why not just use the operator all the time?
You'll still want match in cases where you need more sophisticated error handling, such as logging, recovery, or displaying user-friendly messages. Use when the error handling is straightforward and the errors are similar, like in simple read operations.
That's helpful. It seems like error propagation is fundamental for robust code, especially in systems where unexpected issues can occur.
Correct. It allows functions to focus on their core task, while higher-level code can handle the broader context of error resolution. It's excellent for preventing cascading failures. Just like a financial system, when a critical step fails, it's important to halt immediately rather than propagate incorrect data, which could lead to disastrous outcomes.
Thanks, Russ Jackson. This was a great discussion on propagating errors. Russ Jackson, welcome back to the show. Today we're diving deep into error handling in Rust. Can you give us a quick overview of why error handling is so crucial in programming, especially when dealing with things like file I/O?
Absolutely, Matthew. Error handling is vital. Imagine a program trying to access a file that doesn't exist. If it doesn't handle that error gracefully, the whole program could crash, losing data or potentially causing serious issues.
Got it. So, in Rust, how do you deal with these potential errors in a robust way?
Rust uses the result type. It's a fundamental part of the language's approach to error handling. It wraps up either a successful result or an error. It forces you to explicitly think about what could go wrong.
And you showed us examples of how to handle these in the previous segment.
Yes, in various ways. We can use explicit match statements to check for OK or error and handle errors appropriately.
Right. So, what's this new operator? It looks really interesting. How does it simplify things?
The operator is a shortcut for handling result values. Instead of using a match statement, it checks the result. If it's an OK, it returns the contained value. If it's an error, it automatically propagates the error to the calling function. Very convenient.
Wow, that seems much cleaner than the match statements. How does it work with different error types?
The cool thing is, if a function returns a different error type, the operator takes care of converting the error using the from trait. This trait specifies how to convert one error type to another.
So, different error types can all be handled in a unified way with this tool? That's neat. Could you explain what the from trait is and what it does in more detail?
The from trait in Rust allows you to define how to convert one type to another. In the context of error handling, it lets you convert different kinds of errors into a common type. So if one part of your code returns a network error and another returns a file I/O error, the operator can handle them both.
You mean a single function can return a result that accounts for various types of errors?
Exactly. It makes your error handling flexible and more robust. It's especially useful for functions that interact with multiple resources.
That makes sense. And what about performance implications? Is it faster because it's shorter code, or is it handled differently by the compiler?
The compiler often handles in an optimized way that's equivalent to the match statements. The important aspect is the explicitness it brings to error handling. It's readable and less error-prone.
Excellent point. Let's tie this back to potential financial applications. How could error handling with result and be important in a financial system?
You could imagine functions that check balances and execute transactions. Errors like insufficient funds or network issues would be handled robustly. The operator ensures that any of these issues are reported back without crashing the system.
So, operator streamlines the workflow by handling various errors under the hood, and it's critical for a program that interacts with many resources and functions, like a trading system, right?
Absolutely. It's essential for stability and preventing unexpected program failures in complex systems.
That's incredibly helpful, Russ Jackson. Thanks for taking us through error handling in Rust, especially using the operator. Hey, Russ Jackson, welcome back to the show. We're diving deeper into Rust's error handling today, specifically the operator. Can you explain why it's so critical And what exactly is happening under the hood?
Yeah, Matthew, the operator is a super useful shortcut for error handling in Rust. It's tightly linked to the result type.
Okay, so result. I get it's about outcomes. But can you paint a picture of what it means for error handling?
Imagine you're building a financial application. You have a function that reads a transaction from a file. This function might succeed and return the transaction data, or it might fail because the file doesn't exist or is corrupted. Result is a way to encapsulate both possibilities. A result can either hold a value, success, or an error, failure.
So, the operator essentially lets you handle potential errors without writing a lot of explicit match statements?
Exactly. The operator, when used with functions that return result, allows you to propagate errors upward in the call stack. If something goes wrong in a lower function, the operator automatically wraps the error in a result type.
But what happens if you use it in a function that doesn't return result?
That's a crucial point, Matthew. The operator requires a result or option, or other types implementing std, ops, try, return type. If a function returns something different, you get a compiler error.
So, if a function doesn't return a result, how do we handle potential errors? We have to use explicit match statements instead of, right?
You're right. You can either refactor the function to return result, or you use match. This is a key difference in error handling strategies. Using match lets you explicitly handle different success or failure scenarios.
Why are there restrictions on the main function? Can't we just make it return result too?
The main function is special. Rust doesn't enforce a result return type on main by default to give you flexibility. It can return, in case of a success, or a result for more comprehensive error handling.
Okay, that makes sense. So, for a program that might need more complex error handling, like a financial application validating user input, a main function using result is the recommended choice. And for simpler scenarios, would be perfect.
Correct. The best choice depends on the complexity of error handling needed in your application. Use result when you need to manage and propagate errors.
So, in summary, the operator is a powerful tool for error handling in Rust when dealing with result types. But if a function doesn't return a result, you need to use match for error management. The main function is a special case, and you can choose between returning for straightforward cases and result for intricate error handling. Does that clear it up?
Exactly. Using the right approach makes your code resilient and easier to maintain in the long run.
Great explanation, Russ Jackson. That was a great breakdown of the operator and how it works hand in hand with Rust's error handling system. Thanks for clarifying the implications for financial applications. Russ Jackson, thanks for joining us today. Let's talk about error handling in Rust. It's a crucial part of any application, right?
Absolutely. Handling errors gracefully is key, especially in financial applications where mistakes can have huge consequences.
So, in examples, you often see unwrap or expect. Why are they used, and what are their limitations?
Well, unwrap and expect are useful when you're prototyping. They're essentially placeholders for proper error handling. You might not know yet how to deal with all potential problems.
So, they're a bit like a temporary fix?
Exactly. They're a signal that this part of the code needs more robust error handling later.
Okay, but why use them in testing?
If a method call fails in a test, the whole test should fail. Panic is how you mark a test failure, so using unwrap or expect is the correct way to signal that failure if something goes wrong during a test. It's important that it's explicit. This way, you don't have to track down a failure in one part of a test that has no bearing on the part under test.
Makes sense. So, what would be a counterexample? When would you not use unwrap or expect?
You'd use a more comprehensive error handling system, like result, when you need to deal with different types of errors and return them properly back to the caller. That's the ideal way to handle errors in production code.
So, it's like a choice between a quick fix versus a long-term solution?
Exactly.
In a financial context, what kind of errors would result types help handle?
Imagine a function that validates a transaction. Result allows returning different error types like invalid amount error, insufficient funds error, or network timeout error. These provide much more context than just a generic panic.
That detail is critical. So, we're using result for production and placeholder methods like unwrap in development and test to keep things moving. Understand correctly?
You got it.
Great. Thanks for clarifying that.
My pleasure.
Any final thoughts about prototyping versus production error handling?
Prototyping is about moving fast and getting a functional idea. Proper error handling in production is about building robust and reliable code for real-world applications. You need to think carefully about how different errors could arise and how the rest of the program will respond. It's a critical balance.
Very insightful.
Thanks.
Russ Jackson, welcome back to the show. Today we're diving into error handling in Rust. Crucial stuff, right?
Absolutely, Matthew. Error handling is a core part of building reliable and robust software, and Rust has a unique approach.
Okay, so you mentioned panics. Can you unpack what a panic is in Rust and when it's appropriate?
A panic in Rust is an abrupt termination of the program. Think of it like a screaming alarm bell, signaling a really serious problem that your code can't recover from. It's like,
So, when should we use panics?
use panics when a fundamental assumption in your code has been violated. For example, if you expect a user input to be a positive integer, but it's negative, that's a clear breach of your functions contract, and a panic is the best response.
What about expected errors like network issues or file not found?
For those, you wouldn't want to panic. Instead, you'd use the result type, which lets the calling code handle the failure gracefully. Imagine a transaction that fails because of insufficient funds. A panic wouldn't be helpful. The app needs a way to inform the user.
So, result is for expected failures?
Exactly. Result, it's like a safety net for errors you expect to happen occasionally, like a network timeout in an online banking transaction, or an invalid user input on a financial form.
How does the type system help with error prevention?
The type system is your best friend in preventing errors. Instead of option, if you use a definite type, you're telling the compiler your function expects a valid value. It prevents a user from accidentally passing a nothing value to your function, which would, cause a runtime crash.
Like an invalid amount for a transaction?
Exactly. The compiler will catch it before your code runs, preventing errors. You're making sure your financial input data is valid at compile time, catching potential issues right there.
This sounds powerful, but are there pitfalls to avoid?
Yes. Overusing panics can make debugging harder. And if you're not careful with error propagation, errors can be swallowed. You need to think about how the errors will move through the system and potentially affect other parts of your program.
What about documentation and contracts?
Thorough API docs are vital, especially if a function uses a panic, to explain those requirements and rules. Make sure that you document the contract and the requirements of your code, similar to how a financial institution documents the terms and conditions of a loan.
This is incredibly insightful. So, using panics for truly unexpected issues results for predictable failures and the type system as a first line of defense.
That's the core of Rust's approach. It's a delicate balance, but it prevents a lot of common errors.
Fantastic. This clarifies error handling in Rust. Thanks, Russ Jackson.
Thanks for having me, Matthew.
Russ Jackson, welcome back to the show. Today, we're diving into creating custom types for validation in Rust. Can you give us a high-level overview?
Sure, Matthew. We're building on the idea of using Rust's type system to make our code more robust. Imagine a situation where we're dealing with user input, like a guessing game. Validating the input is crucial to prevent unexpected errors later on.
Right. This is essential in financial applications, too. You wouldn't want a program calculating interest with invalid input, would you?
Exactly. Directly checking the input in every function can become repetitive and error-prone. Custom types provide a cleaner way to enforce validation rules.
Can you give me a concrete example of how this would work?
We create a guess type. It enforces the rule that the guess must be between 1 and 100. This is done by having a function named new which checks this. If the value is out of bounds, the new function panics, stopping execution.
So, if a user inputs a guess outside the range, the program crashes?
That's right. This is different from simply returning an error value. The panic is designed to signal a more serious issue, a bug, in the caller's code. The goal is to make it explicit that there is a problem.
How does this impact performance compared to checking in each function?
The validation happens in a central place during the creation of the guess object. This reduces code repetition and makes the code easier to maintain. Any function that expects a guess no longer needs to check the range of the input.
This makes the code more organized?
Yes, and it makes it more reliable. Using a custom type like guess helps us prevent errors by making sure every guess that's used comes from a place that we know to be valid.
How would this be different from returning an option?
The option would only prevent you from continuing if there was an error. A panic means that something fundamentally wrong happened. So you don't want to allow the user to continue if the input is a string rather than a number, for example.
Interesting. What are the trade-offs with this approach?
The panic call might seem drastic, but this is meant for errors that should stop the whole program. It's better to detect the error early and prevent further potentially bad calculations.
What about error handling? What if we need to handle non-numeric input?
We can enhance the guess type. The parse function could also return an error value, which would then be handled differently.
So, this seems like a strong approach to improve the safety and reliability of our code, especially in financial applications. Is there anything else I should be aware of?
Yes, when you're designing this validation process, carefully consider the documentation and public-facing API. Clear documentation helps to explain conditions that might cause a panic.
Thanks, Russ Jackson, for clarifying this. This is really helpful.
You're welcome, Matthew. Glad to help.
Russ error handling? Huh? So, result and panic. How do these tools really help us build robust financial applications?
Well, imagine a stock trading app. You need to make sure everything works correctly.
Right? Avoid crashes.
Exactly. Panic is like an emergency stop. If something totally unexpected happens, like trying to divide by zero, you use panic to halt the process immediately. It's like slamming the brakes.
So, it's crucial for preventing crashes.
Absolutely, but result is more sophisticated. It lets you anticipate potential problems without immediately halting.
How does it do that?
Think of it like a promise. The operation might succeed, or it might fail, like a withdrawal from a bank account. Result signals that.
Like a return value, but with more information.
Exactly. It wraps either the success or the reason for failure. Your code can then check if it succeeded or failed, and handle it accordingly.
So, you're catching problems before they stop the whole app like a safety net.
Precisely. It's about building more resilient systems. You can provide informative error messages, roll back transactions, or take alternative actions. This kind of control leads to more stable applications.
So, if the account doesn't have enough funds, the result would signify failure, and the app handles that.
Yes. It's how you handle a potential error gracefully, rather than letting the program crash.
Generics? How do those fit in?
Generics are like building blocks. You can create functions and data structures that can work with different types, numbers, text, dates.
So you don't have to rewrite the function for each type?
Exactly. It's reusable and much more flexible.
And how does that relate to option, result?
Option represents the possibility of a value or lack of a value. A user might input nothing when asked for a stock symbol. Generics enhance the reliability of the input.
So, using generic data structures leads to safer and more robust codes?
Absolutely. It's like having a toolkit with adjustable wrenches instead of a set of specialized tools.
Can you explain how these concepts are relevant to managing risk in a portfolio?
Imagine predicting a stock's price. A result can handle prediction failure. Maybe the algorithm isn't reliable, preventing crashes from unrealistic or incorrect data. Generics could apply this functionality for different securities with the same validation logic.
So, you could potentially catch a problem with a calculation early and make more informed choices.
Precisely, preventing a potentially large loss. It's about handling unforeseen circumstances, whether they're in financial analysis or just normal application logic.
Fascinating. What are some potential pitfalls? Are there things that could go wrong?
Overusing panic can hide important errors, and incorrectly handling result can lead to hidden bugs.
You see, you are right. Russ error handling isn't just about avoiding crashes. It's about building resilient systems that can adapt to various situations.
Precisely.